Okay, let's unpack this. Imagine you're just standing in the grocery aisle, right? Looking at a jar of tomato sauce.
Hmm.
What if I told you that getting that sauce just right actually involves calculus?
Yeah, it sounds a bit wild, doesn't it? But we've actually been digging into some source material that explores exactly that.
A connection between like abstract math and pasta sauce.
Sort of, yeah. It's about food manufacturing specifically.
Okay. And our mission here, really, for this deep dive, especially for you, if you happen to be wrestling with calculus concepts, maybe differentiation,
Uh-huh.
is to show how these, well, powerful mathematical tools aren't just stuck in textbooks.
Right, they're not just theoretical.
They solve real, actual problems, like how to perfect the ingredients in that sauce we were talking about.
And the sources really zero in on using the derivative. That fundamental tool you find through differentiation.
The rate of change thing. Yeah.
Exactly. Using that to optimize ingredient levels.
Optimize, okay, like make it the best it can be. But what does optimizing, say, preservatives in tomato sauce, what does that actually mean?
Well, think about it. You need some preservative, right?
Yeah.
Especially with agro-harvested tomatoes. Consistency varies. Keeps the sauce from spoiling too fast.
Sure, shelf life.
But you can't just, dump a ton in either.
No, I guess not.
Too much can mess with the taste, the texture. There's cost involved, regulations even.
Oh, okay.
So there's this precise amount that balances everything. Shelf life, quality, cost. That's the optimum, the sweet spot.
So instead of just messing around in a test kitchen trying things out, scientists are using math to find this exact spot.
That's the idea.
But hang on, how does a derivative which tells you about change, how does that help you find a fixed best amount? That seems a bit weird.
Well, that's the clever part. See, if you can build a mathematical model,
Hmm,
like an equation,
okay.
that describes how changing the amount of that preservative affects something you care about, maybe spoilage rate or some kind of quality score for the sauce.
Uh,
That model often looks like a curve when you graph it.
Right, I can picture that.
And the derivative of that model, it tells you the slope, the rate of change at any point along that curve.
Okay, slope, rate of change. Got it.
So where's the highest quality score on that curve? Or the lowest spoilage rate? It's usually where the curve flattens out for a moment.
Sounds out.
Meaning the slope, the rate of change becomes zero right at that point.
Zero slope.
Exactly. So you find where the derivative equals zero. That tells you the input, the amount of preservative that gives you that peak outcome in your model.
Wow.
It's a quantitative way to nail down just right.
That's actually really cool. So food scientists are basically using the same idea you'd use in physics class to find like the maximum height of a ball thrown in the air
Yeah,
to figure out the perfect pinch of sorbate or whatever in the sauce.
that's precisely it. You're moving beyond simple guesswork,
Yeah,
towards a really precise data-driven approach.
makes sense.
And this idea, using derivatives for optimization, it's not just preservatives. Think about it. Manufacturers could use it for finding the most efficient oven temperature,
Oh, yeah.
or maybe the ideal ratio of different ingredients to get a specific texture. Viscosity, perhaps?
Huh. Wow. It really does kind of shine a light on how this seemingly abstract math
Yeah.
has these direct impacts on stuff we use, stuff we eat, like every single day, puts calculus class in a whole new perspective, doesn't it?
It really does. It shows that understanding calculus, it gives you this lens, a way to see all the hidden optimization problems being solved constantly all around us.
So yeah, the main takeaway here seems pretty clear then. Calculus, and specifically the derivative, that tool you get from differentiation,
Hmm.
it's really crucial for finding these optimal levels in just countless real-world situations. Preservatives in the pantry, sure, but also efficiency in manufacturing, all sorts.
And what's really neat is how this tool, which is fundamentally about change,
Mm.
becomes so powerful for finding stability,
Mm-hmm.
for finding those optimal just right points.
Absolutely. Okay, so here's something for you, the listener, to maybe mull over. Finding the just right amount of something. It's not unique to tomato sauce, right?
Not all.
It's like a fundamental challenge everywhere. Think about medicine dosages
Mhm.
or components in electronics, even just how much time to spend on a task or resources you allocate to a project. How many other everyday things can you think of where hitting that precise optimal level may be found using math like derivatives is just absolutely essential for it to work properly?